Nice to meet you. For this talk, I'm going to explain. I'm not an expert of CPython. I'm just a simple developer of Python. And I would like to explain how to try to find your path in this labyrinth. For this talk, I'm using the last version of CPython, the beta, just Python 3.6. So firstly, my name is Stephane. You can call me Stephane, and I come from Belgium. So if you want to propose me a beer for this evening, there's no problem, okay? The next point is just I'm a fellow member of the PSF, just because I am the organizer of the Python FOSDEM in Belgium. And of course, I'm a Python lover. So, how about the schedule? Firstly, how to start? You want to contribute to CPython. That's very difficult because you have the documentation and you have the community of the CPython core dev, but you don't know how to start. So I'm going to explain that. We will see the result of Python of this expression, 2 more 2, and we will see the result in the CPython interpreter. And of course, a little summary. So that's the first question. How can I start my contribution in CPython? That's the good question. Firstly, maybe we have the DevGuide. So when you start, you have the DevGuide. The DevGuide will explain the grammar, how to improve the grammar of CPython with some files, or how is designed the CPython compiler, and of course many more. You can find how to contribute with Wirtel, or how to find a good expert if you want to modify a part. Example, for async IO, you will ask to Victor Steiner or to Guido. So, if you want to start, you have the DevGuide, but you have also the Core-Mentorship. If you want to start, you have 3 possibilities. Firstly, try on ERC. So you will have a nickname, ask your question to the core dev on Python dev. But the core dev prefer to answer for the internal parts of on the ERC channel. You have the Core-Mentorship, and this mailing list is just if you want to start a new development or try to understand a new feature, or the tokenizer or the parser, I don't know what you want. So you can ask to this mailing list. That's really surprising, because yesterday I used this mailing list to ask to Guido how many tokenizer and parsers can I find in CPython, and the answer is just two tokenizers and 2 parsers. So the next point is just how to find your information. You have a lot of directories in the CPython code, and the main interesting thing is just the doc. Why the doc? Firstly, because you have the reference of the language. If you want to know the new keywords, you will find information in the documentation directory. For the library reference, if you're using the standard library, of course, everybody is using, so you will find it in this directory. You want to work on a CPython extension in C, you will find the CPy reference. And of course, with this documentation, if you want to embed a CPython in your C++ project or with your C project, the documentation is there. Of course, you have the DevGuide and the Python Mentors documentation. So, when you start to contribute, do you know that there is a library for Python? Python is not just an executable. There is a library, a shared library, and you can use it to embed it in your software, in C++ software. In this case, Python 3 is just the command. This command will use the shared library. And the shared library is defined in the Python directory. It's a virtual machine. This virtual machine will use a parser with the grammar, the Lexer, of course, tokenizer, parser, and compiler. And this library will be defined in this file, like Python 3.5. in this case, CPython.6. Okay, in the grammar, you will find the definition of the grammar. It's just a joke because when you start, you want to modify this file, but that's really funny because you have a big checklist when you want to modify the grammar with 10 points. Don't forget to modify this file. Don't forget to modify the ast.c. Don't forget to regenerate the tokens in the tokens library. So, but I have one question. The first one, what's the result of this expression? Do you have an idea? No? I know, 4, but no. The response is just, you will use the command line, the Lexer, of course the parser, the compiler, the interpreter, and the standard library, okay? So the command line is just this thing, python-c x equal to mer2. The Lexer will create the different tokens from the expression. The parser will take these tokens and create an EST, just an abstraction of the source code. And the compiler will create the bytecodes. This morning there was the keynote from Brett Kennan, and there was a good project. I don't know the name, sorry, but you can take this bytecode and try to use it with the JVM, the virtual machine of Java. That's really interesting. For the interpreter, it's just the runtime. The runtime will read the bytecode and try to execute the function in function of that. And for the standard library, it's just for everything. How about the command line? When you start the command line of Python, you will have just the python.c file. This file will be executed with the main function. This main function will use the models, the PyInitialize function, the PyRun. That's very boring. You just want to develop something, but if you want to learn the parser, the tokenizer is the good way. So for the Lexer, you have one function in Python, but early in this talk, I just explained that you have 2 tokenizers in CPython. Firstly, you have the C tokenizer, and you have the Python tokenizer. Why 2 tokenizers? That was my question to Guido. I received a small answer. The first one is just for the parsing when you execute the CPython code. And the second one, to tokenize, is just when you are using PyLint or PyFlake. PyLint will use tokenize.py, the library for Python, from the Python library. Okay? In this example, I just want to show you the tokens from this expression. So we can see that we have 6 tokens with the name of the type and the string. If you create a tokenizer, it's not very difficult. So, with CPython 3.5, we have a new expression, async. Do you know async? That's a replacement of the async IO.coroutine. But async is not a keyword in Python, in this version of Python. It's just a word, async. But I have the proof. Async is not in the keyword list from the library. And when I just parse create the tokens from the expression, I can see that async is just a name. Okay, but it's not really true. But in function of your definition, if you use async before def, we can see that async is just a keyword, a real keyword. Okay, so about the parser, you have the tokens and you want to have your AST. But the parser will create that. We have this function. It's defined in parser in Python run.c. The system will take the expression and will create a tree. With this tree, you can analyze it if you want to make some improvements in your code. So, about the compiler. The compiler will take the AST and will generate the bytecodes. The bytecodes is just some keyword with some arguments. An example, I take my expression x equal 2 more 2, and I compile it to, so I will have the code object. In this code object, with this dump, you can use the this model. This model will generate this bytecode, and we see that we have the load const, store name, load const, what in return value. That's the bytecode. This bytecode will be interpreted by the interpreter. So there's a definition for this bytecode is in this PEP 339. So, but what's the bytecode? The bytecode is just a single numeric and integer in a file in the Python code file. This numeric number will be used for the interpreter to execute some actions. Secondly, the bytecode is portable. The compiler will generate the same bytecode in function of Windows, Linux, OS X, or whatever. And yeah, sometimes one bytecode will have some parameters, and of course, this bytecode can be used by a software interpreter. Some example. This example come from the last version of CPython 3.6. Yeah, we have a lot of keywords, bytecode. If you want to read it, that's very funny. But when we generate the bytecodes, with this simple example, we have an empty file. With this empty file, we can have a bytecode. The bytecode is, in this case, is just load const, nothing, in fact, and return the value. That's very funny. For this expression, when we define a function, we receive this bytecode. Just load fast, it's just to get the value from x. Put 1 in x. Binary add is just to add one value to another, and store it in the stack. And after that, just load fast and return value. This code is not really efficient because store fast and load fast can be resumed in one bytecode. So we have the compiler. This compiler will take the AST and will generate the bytecodes. But sometimes we can have some optimization from the compiler, and the compiler will use the optimization from the Peepholer. The Peepholer is just a small function in the compiler where we have some basic expression, 1 more 1, 1 more 2. The Peepholer will transform the bytecode and will generate a more efficient bytecode. Example. X equal 2 more 2, we can see that in the parameter, in the bytecode, it's not 2 more 2, but just 4, the value 4. The Peepholer is just a small optimizer for that. But when we have if 1, in this case, we will print hello, we have this result for the bytecodes. Load name for the print function, load const, hello, call the function with the parameter, and pop top, we get the result and just load const. Okay, but the Peepholer is really interesting when we have a dead branch. Example, if 0 print hello is the same result if you have an empty file. Okay? So about the interpreter, you have your bytecode, you have the interpreter, and the interpreter will give life to your code. Firstly, the interpreter is just a virtual stack machine. It will execute the bytecode. Okay? A small example with a custom bytecode. I have push 5, push 3, push 10, add pop. It's my empty stack. Okay? I try to add a push 5. In my stack, I have 5. Then I will add 3. Then I will add 10. So I'm using add. I will pop the two first elements from my stack, and we'll add a new version, a new object. In this case, 13. Next point, just add. I will have 18, and after that, just pop. I will empty the stack. So it's just a very basic virtual machine, just implemented. An interpreter is just a loop where you read the bytecode and execute the write function and function of the bytecode. In my example, I have my interpreter. My loop is just in the run, when self-running. So when I don't use a stop bytecode, I'm going to fetch the keyword, the bytecode, and just execute it with the eval function. The eval function is just a small shortcut to call the write function in function of the instruction. Example, I have eval push because I have the push bytecode in the source code. Okay, but did you remember this code for the function? In the interpreter, we will have the definition of each keyword of each bytecode. And this C version, we have the version, the content of this function for the load fast bytecode. With the load fast, we will get the value from the local, and we'll execute the code. So okay, thank you. There's the same thing for the next point, the next bytecode. So for the binary add, I will take two elements from my stack. We'll pump them and just execute the function add one with one and just store it on the stack. For the store fast, that's the same thing. Just store it on the stack. For the return value, just pop the last value from the stack and just return the value. So if you want to read the source code of the interpreter is defined in ceval.c. Of course, we have some keywords, 157, I believe. But just the ceval file has one function, a very big function. So I think that you don't like to have a big function. But in this case, we have a function with 2,000 lines of code. That's very funny when you want to debug it. So my summary is just how to contribute. Firstly, you have to create a user account to the bug tracker of CPython. Secondly, try to sign the contributor agreement, because when you push your code, you will give the rights of your code to the PSF. Thirdly, try to read the DevGuide. And for the last point, just contribute to the Python mentors mailing list. After that, you can try to improve the documentation of async.io. Try to fill some issues if you find a bug. I have one bug. It's not possible to compile CPython on Mac OS X without the library of OpenESSL with the last version of OS X El Capitan. So yesterday there was a new bug. You can try to test the proposed patch, and yeah, sometimes you have a patch for a bug. You can try it on your laptop. Just you will review it. There is a tool for that. You can try to write a patch, for the bug fixes, or else you can try to create a new feature. For example, yesterday, when you compile CPython, you have an option with PyDebug. Debug will show some stuff when you are running some code, a code in the interpreter. But when you execute the code, you only have the number of the bytecode, not the label of this bytecode. Just create a new feature. When you execute it, you have load const or load global, and not 0 or 1 or 2. So yeah, you can start to be stressed. That's my case. Just because you have to wait for 6 months before one review. Just kidding, but that's sometimes it's great. And take your patience, because the patience is the key to success. So thank you. If you have a question. Do you have one question? I have 10 minutes. So, yes, I want to be here. Okay. Next point. No, just kidding. For this evening. So, no questions? Okay. Thank you.